Okay, hi there, I'm Howard. This is just another video of me solving the numerical problem. So we need to find the minimum path sum. Given a grid of n by n, and we don't have negative numbers, find a path from top left to the bottom right. And that is minimize the sum of all the numbers along the path. So we can either go down or go right at any point in time. So we can use the basic approach, naive approach is to use backtracking. So at any point in time, we can have two paths. If we start one, we can go one or three, so on and so forth. So what is the our depth? Our depth gonna be n plus n because in the worst case we can go like this, right? But because we only can go right or down, right? If we go all the way down, if we go all the way down, right? Then we need to go right. We cannot go up over that. Right? So the maximum depth gonna be n plus n. Right? So 2 to the n plus n. Right. So this is our time velocity. The space also n plus n for the stack frame. So to improve the runtime here, we can use dynamic programming to be our DP. Right. So we can set out at the last element, right? So we can put the last element here, right? If it is the last cell and the last column, right? We can set it to 1, which is the value here. Next we're gonna iterate in reverse order, right? Uh, row by row, right? From the last row to the first row, right? And then from the last column to the first column, this way, right? So we look at this number right here, it's gonna become 3, right? Because the sum of 1 and 2 are 3, right? And so if we are at the last cell, bottom right, right? So the minimum number of sum, the minimum sum to get to the last cell is just 1, right? Because it's just the value itself, right? And to get to the last cell, like from this cell, then the best we can do is 3, right? Like 2 and 1. Then for here, it's going to be 7, which is the sum of all 3 here, right? So if we are starting here, right, the best we can do to get to the last cell is going right, right? We don't have any other option. And the sum of them going to be 7. Okay, same for um the column. So now we finished the last row, right? We go to the next row here. So it's just gonna be 1, right? It's gonna be so it's gonna be 2, it's gonna be 3, right? So if we are starting here, right, the best we can do to get to the last cell is to go down, right? We cannot go left. Our only option is to go down, so the cell gonna be 2, right? Same here. If we start here, we cannot go left, right? I can only go down. So the best we can do is 3, right? So what about this cell? So at this cell, uh, we have two options. We can either go right or go down, right? So we just need to see which path is a better path, right? So we know that if we are here, if we are here, right, the best we can do to get to the last cell is the sum of 3, right? And if we are here, the best we can do, right, to get to the last cell is gonna be 2, right? So which path are we gonna take? Of course, we're gonna take the one with the minimum sum, right? Which is 2. So this is gonna be 5, which is the minimum sum. So each cell in the DP gonna represent the minimum sum to get to the last cell. right? So it's gonna be 5 plus 2, right? Which is 7, right? So it makes sense, right? We can take this path, uh, 5, 1, 1, which is 7. This path is longer, right? 5, 2, 1 is 8, right? So we keep going here, the cell. So the current value is 1. So which path can we take? In this case, they are the same, right? 7, 7 and 7. Right? So we can just take either path. So it's gonna be 8, right? Right. 8. This is also 8. Right. So if we are here, the best we can do to get to the last cell, right, is gonna be 6 and 7, right? And if we are here, the best we can do to get to the last cell is also 7. Okay. So I think you see got the pattern there. So this cell, right, is 3. The best we can do to get to the last cell from the neighbor, right, the right neighbor is only 3, right? But if we start from if we choose the bottom neighbor, take us another set, another 4 instead of 7. So we choose the smaller one with less cost, right? So this will become 6, right? 3 plus 3 is 6. And lastly, the last cell, the first cell here, going to be 7, right? 6 is smaller than 8, right? And 6 plus 1 is 7, right? And yeah, we can just return the first cell here after we finish building our DP table. The runtime will reduce to OM by N, and the display complexity is N by N. It's slightly worse for display, but the runtime is much better. So let's go this up. We're gonna have the row, column, go to 2.9, column equals to 2.0. Use our QT, of course, QT length of rows, and then the column, we need the iteration uh, left, right to left, right from bottom up from the last cell. So row equal to row minus 1, row minus minus, and then same for column. First, we need to check if it is the last row or not. But if it is the last row, right, then we cannot check the bottom neighbor, right? And if it is the last column, right, we cannot check the right neighbor. Yeah. There's no right neighbor for the last column, and there's no bottom neighbor for the last row. Okay, so also need to see if it is the last cell, the last number, which is last row, right, and then last column. Right? Because there's no left and right neighbor for sorry, there's no right and bottom neighbor for the last cell, the last number, right? Only the DP of a row and column will be equal to the value in the grid, right? Row column plus something. So if it is the last number, which means there's no bottom or right neighbor, so we just return 0, right? The which means the value at the last row, that the last row and last column, the last cell here, just gonna be equal to the value in the grid, because grid row column plus 0 is still grid column, right? if it's the last row, then we don't have the bottom neighbor, so we only set it to the right, right? So the row, the right neighbor is column plus one, right? And if it is the last column, we set it to so if it is the last column, there's no right neighbor, so we set it equal to the bottom neighbor. So plus one column here. And remember, it is the sum, right, of this and the current cost at the sale, right? And the last case, right, if it is not the last row and not the last column, which means they both have the right and the bottom neighbor, right? So you just check the minimum, right, of the right and the bottom. Okay, and we can return the BP at the first cell at the end when we are finished building our DP table. So let's try that. It'll work. We do very well with the runtime here. So thank you for watching.